It's probably fair to say that prior to this government initiative, the UK has not had a great track record in bridging the gap from the outputs of scientific excellence all the way through to commercialisation, where venture capital money or big industry money will kick in a large way. So we've had a gap for a long time, and the last few governments have started to appreciate that, and I think pick particular areas where they think there is some support or some support should be put in for that. And so they've done it with other areas. They've now done it in a very significant way with quantum technologies. And so that injection of money, I think, was extremely welcome, because the UK has had a long tradition of very high quality scientific research, and so now we can start pulling some of that through all the way to technology.
The scientific community, I think, is now recognised that funders have charged us with a responsibility to get our basic science into industrial innovation and to make economic and societal impact from it. But as an engineer myself, I've been involved in that process for a long, long time, and I think the beauty of this program is the fact that A, it's an imperative, and B, that the funders are giving us a lot of freedom as to how we go about achieving that industrial engagement. So our approach is to try to excite our industrial collaborators with some novel imaging technologies so that we have them fully engaged in the program and willing to wait for a little bit longer to see what the quantum space will open up for them, as opposed to waiting for 5 years until all the scientific work is done and we can deliver something into their hands.
Oh, we are very pleased with the industry engagement. The Quantum Technology Initiative has really got the industry interest up. So they are talking suddenly to physicists, which they usually wouldn't do in terms of development and research. But it really has helped a lot in getting interest, in getting communications going, as we have over 70 industrial partners in our hub. Most of them are end users who are interested to be briefed on the potential final uses, the disruptive uses of the quantum technology. We get them to think about the potential disruptive opportunities in the markets to help them grow their business in the future, while they give us the triggers to know what kind of parameter ranges do we have to look at when we are working on doing our prototypes.
We have resources to help our partners, who we have already, and new partners, do two things. One is understand our technology needs and try and provide technologies for us. And the second thing is for us to help them understand what quantum might mean, about what quantum computing might mean for their business in the future. So you imagine a financial institution asking a very broad question: what would quantum computing mean in 20 years' time for us? We can address that question with the resources and the team that we have. We'll also work closely with the other hubs. What we really want to do is pass on the questions we get asked to the best people to answer them. That's one thing. The second thing we want to do is make sure we link up with the other hubs to address common engineering challenges together.
I think the principle that the program has established, that this is investment in order to generate a UK industry in quantum technologies, I think that is novel and very important, and it's important that the program keeps that at the front of its mind, that as the hub directors say, that the scientific work is focused on bringing new products to market and building a supply chain and working closely with industry. Because it's new, I think it's a challenge. It's a challenge to the industrial side as well, because the science is new, it's unknown, it's novel in every way, scientifically as well. And so there's an engagement that needs to happen to get all parties to understand each other. But I think there's the beginnings of that happening now, that UK companies are providing products into the research work of the hubs and of NPL. And then those products may need to be refined and modified and improved, and that, I hope, will build innovation in the UK industry, which which leads to something bigger as the years progress.
The funding from EPSRC, though it is the Engineering and Physical Sciences Research Council, is not just to further research. It's about technology transfer. For me, that makes all the difference. That is the difference in this program, because by definition it's a program very forensically targeted, an intervention, if you like, which is specifically aimed at technology transfer, but on a national scale. So if you combine that policy requirement, you combine that with the distributed nature of the approach, i.e. it's not just one university, however good, it's a collection of universities, and then you bring in the private element as a requirement, I think you've got a magic recipe. So I'm very optimistic. What I would like to see actually that this program becomes a template, if you like, as an intervention for getting great ideas and great technology out of universities into the private sector, driving national economic wealth. At the end of the day, we invest a lot of money to great effect in higher education and research in this country. It's something the nation, I think, is rightly proud of. Ultimately, that has to be to the benefit of the nation through economic well-being. And I think programs such as this, it's early days, but I hope in 5 years' time we'll be looking back on this and reflecting upon the success and reflecting upon the carefully structured policy intervention that's led to that success. That's my hope.